Yeah,
together.
it looks like it's going together. Excellent. So this one is going together. So we have an A plus B, and then we have AB. And what we're going to consider this reaction, we'll go over them, is a synthesis reaction. So it's when two things are separate and they come together, that's your synthesis reaction. So Haley, since I've got you here, let me ask you about this second one. Now, on that second one that I'm going to highlight right now, does it look like they're going together or breaking apart, Haley?
Haley says that's kind of tough because of the plus sign.
Oh, I see. Well,
But
you had the plus sign in the other one too, just on the other side.
But Haley says, I think apart.
Yes, excellent. So this is going to be a reaction that is the opposite of synthesis. And we'll call it decomposition. All right. I just realized something. I've got a lab already set up for my AP Chem stuff. That is a decomposition reaction, but I don't think you guys want to see it.
We want to see it.
I don't know. I need to hear from someone that I haven't heard from all class if I'm going to run this reaction for you guys.
We really want to see it.
Who the heck was that? Was that you, Mr. Ritchie?
I have no idea. Some KB student.
You guys are deranged, but that'll work. That'll work. So here, let me present this to you guys. And I actually already ran the reaction, so it's a little messy. Oh, yeah. Wow, that's interesting looking. I don't know what that funky stuff is. Let me rinse this real quick. So every one of you guys probably have this chemical at home that I'm going to show you. It's the stuff that you typically will use for cleaning, say, earrings or any sort of jewelry that comes into contact with your skin. And we can also use it for treating cuts and cleaning up cuts. Can anyone tell me what that thing is?
Ooh. Is it red colored or rust colored?
Nope. This is what it looks like in a bottle. But usually it's in a brown bottle. And I think this shows you backwards print, but this is, where are you? There we go. Oh, you can't really read it. Hydrogen peroxide. So this is really strong hydrogen peroxide, the kind of peroxide you'd need if you wanted to dye your hair blonde. So the stuff that you get from the store is in a brown bottle. It's usually like 3 or 4%. This is 20 or 30%. So you can only get this at special places. But what's cool about it, well, the hydrogen peroxide at your house will decompose naturally over time. It'll become water and oxygen. So it doesn't do its job if it's just water and oxygen, because you want hydrogen peroxide. So what I'm going to do is make a little solution here real quick to show you guys. And this solution here is a catalyst. So this reaction is occurring right now, but can you tell that it's occurring? Can you see anything?
I can't.
No, that's just hydrogen peroxide, right?
Yep. So
Okay.
it is decomposing, but at a super slow rate. After about 3 years, your hydrogen peroxide will just be water. So we can speed it up with what we call a catalyst. And that's what I made here. But to make it more fun, I'm going to put some, because this is going to produce some gas. So we want to be able to see the gas as bubbles. So I'm putting soap in here. And then, of course, bubbles are always fun with a little color. So I'm putting some food coloring in here. so that we can see the reaction proceed. Now I've got my hydrogen peroxide in here, and I've got my, well, this is a catalyst, which will speed up the reaction, and it's got soap.
And what
So
is
right now,
and what is
I'm
the
sorry.
chemical that is the catalyst?
Potassium iodide. And let me write that on the board real quick. So I'll write on the board without tripping over some cords. I don't know if you guys can see this reaction so well, but it's, and this might be writing it backwards. Tell me if you guys can see it okay.
Yeah, we can see it.
Why is someone calling me? Oh, someone was. Okay, so you guys can see it okay. So this shows your hydrogen peroxide breaking down to water and oxygen. Now, I put potassium iodide as a catalyst. I put it over the arrow because it's not being consumed. Let me check my phone real quick. Miss Aubin?
Get out.
Yeah, I'm got a class.
We'll talk to you later. Bye.
Oh yeah, I'm back. All
Yeah.
right.
No idea.
Sorry, what was that?
Nothing, Mr. Robin.
Okay. All right. So now we're speeding up this reaction with soap. The nice thing about the soap is it's going to catch all the gas. And I better step back because this might be stronger than I did for my AP Chem class, and it gets really messy.
That is super cool. Oh my God, it's still
Yeah.
going.
Yeah, crap,
Oh my
crap, crap,
Uh-oh.
crap.
Yes.
Sorry, guys. I had to throw it away.
That was,
But when you guys come to class, I can do it for you in front of you. I just didn't want to clean that mess up because it's got iodine in it. So sorry, let me show you the sink. That was sort of lame for you.
Chemistry.
I think this is how that blob started.
Oh, looks like my screen froze. Did it?
Yeah, this is just how the blob starts, just like this.
I don't know why that's frozen now. Oh, well. Well, let me wipe my hands off. That's got iodine in it. And if you know anything about iodine, it'll stain your clothes and your hands and your skin. Let me just clean that off before I get it all over my clothes and myself.
Thank you for sharing that. That was not expected.
You're welcome. I love doing stuff like that. But you know, when teachers are sitting down and trying to hyper plan things, they try and predict how these situations will arise. And it's sort of, it doesn't really happen that way all the time. Awesome. So let's switch the camera.
It would be sweet if that whole room was starting to fill with orange slime.
Actually, that sink is. Oh, I love that reaction. I'm so sorry I had to throw it away so quick, but if that iodine gets on the floor, it gets all over everything. And I'll clean it up as best as I can. But Maria, the cleaning lady, is really nice. And I'll come in early in the morning. She's like, oh, I'm trying to get this stain up. I'm like, dude, don't you worry. I'll take care of it. Because that's sort of a pain. And it takes a while. But it does come up. All right. I hope that was an interesting reaction for you guys. Awesome. All right. Now, hopefully you're seeing what I'm seeing. All right, good. So we're gonna move on a little bit now. We saw that this is a synthesis, this is a decomposition. This third one here is gonna be something different. And we're gonna look at these kinds of reactions the week after next. This is called a single replacement because one thing is replaced by another. This C will replace the A. See how that works? And the nice thing about looking at chemical formulas this way is you can actually predict what something will make just based on these very simple formulas. Now, a more challenging warm-up was this second part. And that's going to be on the, on the next slide. So this was a slightly more challenging one that you guys can fill in as well. You do not have to. This is a more challenging one. All right, so the whole point of what we're going to be exploring this week is to be able to identify synthesis reactions, begin to write them from word equations, and predict their products possibly by applying the patterns that you see from the synthesis of water. Some of the terms you're going to have to use today or throughout the week, and we have been using them last week, is coefficient, subscript, reactants, products, phase script, and synthesis. Those 5 things. As far as the outline for this week, we're going to be looking at what making water has to do with types of reactions. We're going to look at how on Mars you would possibly make water so that you could exist. If you've seen the movie The Martian, we're going to have a little clip from that. On Wednesday and Thursday, we're really going to practice drawing these reactions, because if we have a reaction like the hydrogen peroxide that I drew behind me, let me see. So that reaction that we did, the H2O2 breaks up into water and oxygen. I'm going to ask you guys to draw that, and hopefully you can sort of see where my camera is. So you would have to know that there are 2 hydrogens attached to 2 oxygens. Doesn't matter how you put them. And you'd have to show that you're going to end up with water and oxygen. So to be able to draw these representation, a particle representation, is the main skill from this week. And I do have some extra credit too. If you guys want extra credit, even if you don't want extra credit and you're not doing so great on counting atoms, I've got an extra credit homework where you're going to have to practice counting the atoms. And finally, on Friday, we're going to have what we call a BARC test, which is we're going to do a demonstration and have an assessment based around that, where I'm going to be making hydrogen, and then we're going to be lighting it on fire just a little bit. But that's what's going to happen on Friday.
Fire.
Fire. Oh, and I don't know why I'm still on week 3 in my head. This is one thing about not having a pair deck. Yes, I can change it when I make mistakes. All right. So this week, we're going to be working all this week in this document. Every activity we have, I've gotten set up for you in there. So all you've really got to do is follow along.
If any of us are still struggling with the coefficients, I think that's what it's called, the counting and all that, would you recommend going back and studying the old homework from last week to get better?
Yeah, I would say if you have trouble counting, try the counting atoms activity that I've assigned for this week. Now, when you're talking about the coefficients, I would say don't worry about last week, because the idea that we're continuing the semester with is we're going to practice balancing equations with coefficients this week with a synthesis reaction. And then next week, when we do a decomposition reaction, we're going to practice balancing those. So we're going to get more practice on that.
Oh, I see. So it's just hang in there.
Yeah, that's a good question though. But you did bring up a really interesting point, and I sort of struggled whether or not to just have you guys working on the counting atoms extra credit today, because we do need to make sure you guys can do that. And I opted to just introduce this and leave it up to people to try that on their own. I hope that's a good enough solution, but we'll see.
Hafsa's wondering how much of the guided notes to do. So Hafsa, as we go through, when we end, you're done with that section of the notes. Does that make sense? So just do as much as we do in class together. Okay, cool. Thanks.
Awesome. So you'll see that I've got a question here. The question says, what are the reactants and products of this reaction? And we're going to watch a little clip that's based on making water for going on Mars. You'll notice that this is similar. Where'd you go, my little document? You'll notice that this is similar to your guided notes because what reactants and products are there of this reaction? So there you go. You're going to put that in there. So let me get back to the presentation and I am going to play this. I've got to change my projection mode. Oh, good Lord. Just a sec, guys. All right. Hopefully you guys are able to hear it while I'm going to play it and see it okay. If you cannot, please let me know.
Hey people, welcome to the planet Mars. Hey people, welcome to the planet Mars. Well, it's actually the Utah desert. However, the guys behind the new movie The Martian kindly invited me to visit this place. Specifically to the Mars Society Desert Research Station, which is a facility run by scientists where they research about the possibilities of living on Mars. And here I am, stranded, just like Mark Watney in the film. Well, kind of. Now, if there's one thing I'm going to need in this place, as well as food and air, it's water. And in this video, I'm going to show you how to make water in the same kind of way that Mark Watney would have had to do it on Mars. Now the guys at the research station have kindly set up this nice demonstration for me to show you how it's done. So let's go through the apparatus you'll need. We'll be creating water by burning hydrogen, so a compressed tank of hydrogen will be needed. We'll also use a condenser glass to collect the water. The red thing is used as a weight to keep it in place. Now this spiral tubing contraption attached to the clamp is used to help cool the mixture of hydrogen and oxygen. There's also a small valve on the left hand side, which is where I'll be attaching the hydrogen flow. The hydrogen and oxygen will be burnt in this large flask, which will be placed upside down on top of the contraption. We'll also use a fan to help with the cooling process, and a vacuum to help suck through the water. Right, let's get to it. First of all, I placed the large flask over the cooling tube and hydrogen valve. I placed the other side of the tube with the rubber stopper into the top of the condenser flask. Then I attached the pump to the condenser flask. Just need to attach the hydrogen line and then turn on the fan and the pump and we're ready to go. I allowed a small amount of hydrogen to start flowing from the tank. Now comes the dangerous part, igniting the hydrogen. Luckily for me, it didn't exactly explode. Now it doesn't look like much is happening, but in fact the hydrogen is burning with the oxygen inside that flask. The flame is actually invisible. I then made sure the seal was tight and allowed more hydrogen to flow through. After a minute or so, water begins to condense and drop into the glass. The condensed water from the burning of the hydrogen and oxygen is cooled with the aid of the tubing and the fan, and then gets sucked through into the glass via the pump. And there we have it. That's how you make water on Mars.
Okay, guys. I liked that Sebastian brought up the invisible flame because it got me thinking about the frequency and wavelength of light that we were discussing. So the reason it's an invisible flame is because the wavelength of light is outside of our ability to see that part of the electromagnetic spectrum. Let me just change something real quick so you can look at my face and not at the table. Cool. All right. So I'm going to give you guys a few minutes. We'll try 2 minutes. What are the reactants and products of this reaction?
Don't overthink it either. It's not,
Yeah, don't overthink it. And Jasmine, make sure that if you're having trouble following along, that you're asking. I don't see your first warm up in there.
and if you're stuck, just remember, you know what the product is. So conservation of matter.
Stephanie, you're right about your answer, except for I'm asking specifically, what are they? We know that one of the products, the only product actually, is anyone? What are we making? And it tells you right at the top of this slide.
Let me give a little slight clue here.
Yeah, water.
Away from your classmates. Thank you.
We've still got 2 minutes of class. All right. So for your next question, and this will probably be the last question for today, I want you to use the definition above and make your own definition for what a chemical equation is. And let's call this an equation.
Hi.
Hey, Yana, you're a little early.
Am I too early?
No,
Yeah,
you're
the
good.
previous class.
Oh.
Come
How?
back in like 3 minutes. Or relax.
Good to see you, Yana.
You too.
So to clarify for the class, what you should have gotten through is up to here. A sub B, your definition of a chemical equation. And we'll pick it up from there next class.
What about the conversion of matter check-in?
I don't think that that's for today. I don't, let me see.
Okay, I
Okay.
just wasn't sure.
Yeah, it's not for today. Hopefully I wasn't that ambitious. Yeah, that's for Friday. All right, folks, it's time for you to head out to your
Mr.
next
Ritchie?
class.
Yeah.
Do you think you can help me with one of the quizzes? Well, the quiz from last week.
I don't think it was a graded quiz, but we can.
Oh,
It was for completion.
Yeah.
So just
because I think I got a B. It's the matter check-in, the conservation of matter check-in.
we can chat at the end of class, Iana.
Okay.
All right, folks, if you are in my 5th period class, you should be heading to your 7th period right now. And Mr. Ritchie, I'm going to get that lab set up again.
Yep. I say make it even bigger.
Yeah, it's just a mess. Maybe, well, the thing is the camera won't go all the way to my sink. So I'm sure there's a way around it, but I just don't feel like it right now.
Right.
Oh, June, what a jokester. June. Someone loves Blues Traveler. Uh,
June, you like Blues Traveler? Really?
I think that's what he was referencing was that song Runaround.
Yeah.
Yeah,
Now
they're
I've got
pretty
that
good.
song in my
I'm just surprised that you would like them.
Yeah, their music's pretty good. I really like the blues rock soul fusion.
Yeah.
Once upon a midnight. Oh, I don't know. Can't sing it. Oh, why you wanna give me the round? It's an early song. I'm surprised that's on your radar.
Oh, I heard it in like a video or like at the mall one time, and I thought it was really catchy.
It is. I mean, it's a very catchy song.
I hope I'm not getting iodine all over my clothes here.
Oh,
Oh, all right.
hi, Jackson. Melody, how was your weekend?
It was pretty good.
Do anything fun?
I don't even remember what I did. So probably not.
I
How was
think
your weekend?
I think it was like yours because somebody asked me that earlier too, and I was like, "What did I actually do this weekend?" I remember my
Yeah.
the football games, and I remember my daughter being really crazy. But yeah, it was a bit of a blur for me too.
Yeah, I don't even remember what I did.
That's funny. Your day's going okay?
Yeah, it's been pretty good. I woke up really early though.
Uh, are you in you're in cohort A or B?
I'm in A, but I'm not going.
Oh, you're on virtual?
Yeah.
I see. How many of you guys are in cohort A? Drop a 1 in the chat if you're in cohort A. and maybe drop a 2 if you're in cohort B. And a 3 if you're in cohort C. Okay. So some of you we'll see tomorrow. That's exciting. Like, I've never met you guys. Some of you I've met in person from last year, but a lot of you I've never actually met.
I never met you before.
What?
Yeah, I don't remember you.
Yeah, me neither.
From Mr. Davis'
Yeah.
office, Deanna?
Huh?
From Mr. Davis's office?
Oh, yeah, I remember.
I was gonna say, what? You definitely have met me.
I'm joking.
A little bit hurt, Deanna.
Wait, so we only go this one time until February 9th?
Yeah, because we got to get everyone, like, show everyone what the protocols are, and we don't want to do that with too many people there at once, you know?
Awesome.
Yeah, true.
All right. We're going to get started and discussing the schedule. I'll have that schedule up so you guys can see what day, if you've chosen to be in person, what days you're going to be in school. Just to preface what we're going to do today, to give you a little background, we're going to be putting our answers in this week's week 4 guided notes assignment. So that's in Schoology, and what I would recommend is, even before we start on the warm-up, is you guys open this document up, because this is where you're going to be putting the warm-up and any answers from today. I'll show you where to find that.
Thanks, Mr. Robin.
You're welcome. I'll find you guys where to find that. It's going to be here on the right side in the class, like it always is, week 4 guided notes. And you'll click on that, and it'll open up a document that looks like this. Of course, yours will look a little smaller if I make it at 100%.
There we go.
It should look like this. And I've also got a link for the presentation too, in case you wanted to follow along. So let's get started. In the chat, I would like to hear how you're doing. And I want you to choose one of the terms from the space that says how you're doing. For me, I'm feeling anxious, worried, and unsettled. I think more than anything, I'm just anxious. So that's what I'm going to put in the chat. I want to see how you guys are feeling. So I'll give you guys about a minute. Ready, set, go. Mr. Ritchie, where'd you get the word uncomfortable? Is that in there?
I'm feeling because I didn't get up and move between periods, and I've been sitting in this chair too long, and I'm like literally uncomfortable.
Yeah.
I have to get up and stomp my feet or something.
Yeah, I feel better being in the classroom just with the workspace that I have. Because of my house, my wife and I have a very small house. So at least here I can spread out and do reactions without the reactions destroying my house. And I'm going to do a reaction for you guys today, actually. And you're looking at the setup right now. I speak with my hands a lot, and I've got to remember that you guys can't see my face with this setup.
A lot of people are feeling anxious.
Yeah.
That's normal.
Yeah, in our last class, we had a lot of calm people. And Connor, there is no link for the Pear Deck today. We're not doing Pear Deck. Yeah. Would I be able to ask someone to share out either why they're anxious or why they're calm? And hey, Zach Morrow, sorry to pick on you, but I figure you'll answer if I ask you. Are you there, buddy?
He
Cool.
says yes.
So why do you feel calm? And again, to you guys, there is no link for the Pear Deck today.
Yeah, Alan, we're just following the slides.
Well, Zach is calm because he's just chilling. Cool. And for the sake of time, I'll just share why I'm anxious. Um, it's just normal. I feel like every week the earth is shifting under my feet. So there is no normal. So I've got to constantly be on alert, I think. Um, and just like setting up the seating charts so that kids are safe in the class, getting used to this whole new schedule. And that's one of the reasons I'm showing up today. I didn't have to show up today, but it's important for me to deal with my anxiety to get here early. And just know for me that it will lower my anxiety when you guys do show up tomorrow because I'll know about my technology and how things are working. So I think one of the ways I deal with anxiety is to try and be over prepared, which only goes so far sometimes because there's only so prepared you can really be. I told you guys I would share the calendar of when you guys are showing up, and this is it. So most of you guys are sophomores. So you're either in cohort A, if these are your counselors, or you're going to be in cohort B, if these are your counselors. If you're in a cohort that doesn't meet that day, you'll be dialing in just like normal. Everyone will dial in, even if you're in class, and we'll conduct the class virtually, just like we have been. So if you're in the A cohort and you're a sophomore, you'll be showing up tomorrow. If you're in the B cohort and you're a sophomore, you'll be showing up next week on February 5th. All right, so I think, a good reaction. I think we'll do the warm up and then the reaction. Is that how we did it last class, Mr. Ritchie?
Yeah.
Okay, because I think the reaction we're going to do is very similar to this first one. So what you'll notice, well, first thing you got to do, open up this document for week 4 guided notes. You will find that up here where it says week 4 guided notes. When you click on it, it'll open up something like this. I'll tell you guys, any place you do have to write something, I've highlighted the text. Highlighted. Just because a lot of times it's hard to figure out what you're supposed to do in some of these documents. So everything that you need to respond to is highlighted. Thanks, Mr. Robin. You're welcome, June.
Thanks, Mr. Arbin.
Oh, I didn't share that window. So yeah, thanks, June. So these are highlighted. So I want to make sure everyone's got this open before we start on the warm up, because otherwise you're not going to know where to write it. Can I get a 1 in the chat if you're ready to go with your week 4 guided notes open? Thanks, Iana and Caleb and Eve and Eduardo and Zach and Bianca. And Jackson. Cool. Is there anyone who doesn't know where to find this document. Please speak up right now because I don't want you falling behind. All right. So the warm-up, you're going to put in this first box I'm giving you. It says, what patterns do you see? And this is the image that you're responding to. It's the same image that's in the warm-up slide. So I'll give you guys 3 minutes. You can't see my fingers, but I held up a 3. I'll give you guys 3 minutes to respond to this warm-up while I'm getting this reaction set up. Starting a timer right. Ready, set, go. All right, you guys should be wrapping it up in the next 20 seconds. All right, so that's time. So I'm going to call on 3 people to help me out. Hopefully you guys don't mind. I'm going to call on Bianca. I'm going to call on, let's see, Dane. And I'm going to call on Honey. Hopefully you guys are able to unmute and talk with me. Hey, Bianca, are you there?
Bianca responded in the chat. She said, I didn't really know what to write, so I just said, a pattern that I see would be the letters on the reacting side are the same as the letters on the product side.
Yes. Awesome. So that's an acceptable answer. That's a pattern that you see. You see that whatever you see on the reactant side is going to be the same thing you see on the product side. And if we look over here, right over here, this is the reaction that we're going to be doing. So we've got a reactant side and a product side. Awesome. Let's see. Dane, what's something that you saw?
Hang on a second, Connor.
We're not hearing from Dane, are we?
Connor, did you want to answer that question? Connor put his hand up.
I wanted to say, if I leave the class randomly a few times, my computer today has been bugging, so I'm just sitting here waiting for you guys to say something, and I look up and you're both talking, and I can't even hear you. So I have to sometimes restart the Google Meet, but...
Okay. Appreciate that, actually. That helps us understand what your experience is like. Thank you.
You're welcome.
Yeah.
It's really annoying.
Right?
I feel your pain.
Well, who was our third person?
Our third person was going to be Honey. Hey, Honey, are you out there, buddy?
Yep. He says, okay, go ahead, sorry.
He says, I see the formula for the first and second are similar. Really good observation. Can you explain how they're similar? Oh, no idea. Well, you're right that we've got A and B gives you AB. Look at this. What if we reversed this right here and put the A plus B on one side and the AB on the other? Huh. It looks like the second reaction is just undoing the first. So this one looks like something goes together. And then this one looks like something breaks apart. So we'll just look at these first two. So the reaction we're going to do is going to be like this one. We call this a decomposition because it's breaking apart. The reactions we're studying this week are synthesis reactions, so they're coming together. We have two things separate, A plus B, and then they're going to go together. So that's the reaction that we're studying this week, is the synthesis, but I'm going to show you a decomposition just because it's really fun to look at. So can you guys put a 1 in the chat if you're ready for the reaction that I'm going to do?
You want us to do what now?
Put a 1 in the chat if you're ready for me to go over the reaction.
Okay.
All right, so the reaction we're going to do, and let me actually just do this. I'm going to stop sharing. I can see myself. Cool. So the reaction we're going to do is we're going to take something that you guys have at home probably. And Mr. Ritchie, is this backwards for you guys?
No, but you're really just a tiny little box. We might need to like.
Oh, they're gonna have to pin it.
Yeah, you guys have to pin him to your screen so that it zooms up. So otherwise you won't see, but he'll be just a little tiny box there. So if you're to do that, you just click on his picture and you'll see a little pin on the left center. You click on that. Whoa, sorry about that.
What happened?
My audio went completely nuts, so echoing. I don't know if you did. You guys hear that, or was it just me?
Yeah.
Yeah.
It
It
went.
might have been. It might have been from my end. I don't know what happened. I was just trying to share the screen to make it bigger, but you guys are just going to have to pin me.
Bruh, I can see Mr. Arvin in 180p.
180? Oh, that's awful. All right. So the reaction we're going to do is we're going to take hydrogen peroxide and it's going to decompose into this gas and this liquid. So this is O2. I'm going to mark it a gas. I'm going to mark this a liquid. And this is a liquid. Now, you guys have this stuff at home, and now we're going to switch over to the other camera. So at your house, it probably is in this brown bottle, but the stuff you have is 3%, which is pretty low concentration. So if you go to a hair salon where people bleach their hair or a chemical supply company, you can get 30% hydrogen peroxide. Doing a little lab. Do you need something? Oh, okay. Oh, I don't need my. Yeah, you should hang out and watch the reaction. So I just got a visitor. Sorry, guys. So you've got hydrogen peroxide at home. That's 3%. This stuff is 20 or 30%. And peroxides are really reactive. Now, if you have hydrogen peroxide at home sitting around, it just converts into water. That's all it's going to be. So if you open it up and use it and then close it up, in about 2 or 3 years, it's just going to be water. And that reaction takes time. Now, I've put about 30 milliliters of hydrogen peroxide in here. Can any of you guys see a reaction right now? Can you see any indications of a reaction?
Tiny bit. It's kind of yellow.
Tiny bit. It's kind of yellow. Yeah, and that might be partly from this stuff. It'll look less yellow now. That's pretty clear. But I can't see any bubbles. What we're going to do is speed up this reaction by adding a catalyst. So I mixed in some potassium iodide into water. And you guys might have heard of this. It's called the elephant toothpaste. Have you heard of it? So what I do is I just add the catalyst to this, and it's going to speed up the reaction a lot. Something else I did, I put soap in here. Can anyone tell me why I use soap? Well, just think, this is going to be making a lot of gas. If we have soap in there, what are we going to get a lot of?
Bubbles?
Bubbles. Okay. So what makes bubbles a little more interesting is a little food coloring because, well, it's supposed to be fun. And that just means I run the risk of getting more stuff on my clothes. So I'm going to put a little dye in there so we can see it. All right, now we're going to add it. Let me get some of this stuff out of the way. What do you guys think is going to happen? What do you guys think is going to happen?
Yeah, just take it. He saw Jackson said explode. Connor said
Change color.
we got to change the color. Good.
You guys have got all those. Yeah. Not really an explosion, thank God. But let's take a look.
Whoa.
And it'll look more impressive when you can see it billowing out at the top too. And get a little closer.
That's cool.
Look at all those bubbles coming out. What gas is that? Uh-oh. Uh-oh.
Bubble gas.
Oh, it's all iodine colored. Oh. Whew. You guys will see my sink will probably fill up. Can you guys see that?
Oh, it is filling up. Look at that. It's overflowing.
Yeah. But when you guys are here in person, this is something that we can do just as a fun reaction for the class. And what do you think I feel above it? Do you think it's cold or hot?
What do you guys think?
Warm?
Yeah, Yana? Yeah, it feels warm. So above it, there's actually steam coming off of it. And I'm looking forward to when you guys can be in this class with me so you can see it and feel it and maybe even smell it.
We don't want to bring fire near that thing.
Well, that actually wouldn't be, oh, actually, yeah, it wouldn't be that great because it's oxygen gas.
Yeah, that would be bad.
Huh. So that gets me thinking, if I take a match and put it out and then stick it near there, will it relight?
Ooh.
This is where Mr. Oven blows himself up.
And we have it recorded. That's great.
No, it won't. Just the bubbles put it out. But oxygen is very flammable. Well, it allows fires to occur. Yeah, it is warm. We call that an exothermic reaction. It releases a lot of energy, the energy that's trapped in those bonds. So the bonds are being rearranged, and when they get reformed, they release a lot of energy. I hope you guys enjoyed that demonstration. It's one of my favorite ones. Mr. Alvin, that was so cool. You're welcome.
I wonder if you had a pole and a flame and we're able to get towards the center of that, because that's pure oxygen that's in there. Yeah, well, yeah.
The fire would probably be going pretty well, but you're right. I would want to do it at a distance because that sink where all that stuff is right now is where I almost lost my hand doing something stupid. So I'm very careful. It surprises me daily, like how fast some chemical reactions can happen. We always think we'll light it and run away. I mean, think the airbag in your car is a chemical reaction. You can't outrun that airbag blowing up in your face. Some reactions happen extremely quickly.
Yep. I learned that when I was 10 years old and I bought a box of fireworks, like a whole box of them. And I was going to do my own fireworks display. Well, I did about the dumbest thing you could do. I lit a sparkler and I just stuck it in the ground, right? As like, well, the sparks went into the box.
Mm-hmm.
And the entire box of fireworks exploded.
Oh, yeah.
It was like a Bugs Bunny moment.
Well, and that's the thing about science is you've got to make mistakes, but hopefully you make mistakes in a safe enough way so you can continue to make them.
There was a cherry bomb that blew up and the lit firecrackers went flying every direction, and I just ran for. I had to like lay down with my head covered as everything in the whole box went up.
And how old were you?
10.
Yeah, sounds about right. I'd probably still end up doing something like that at my age. I just figure, well, I'm old enough. I'm allowed to do this. Oh, but of course, I'll go to jail if someone gets hurt because I'm over 18. Okay, folks. So the whole point of what we're doing this week is to identify synthesis reactions, reactions where we have two things that are separate that come together, and begin to write them in word equations. And we're also going to be working on balancing these because we are going to be working on that skill this week and next week and the week after. So if you're still having trouble balancing equations, that's fine. You'll have more chances to do it. Some of the terms I want you guys using, similar to last week, the term coefficient, subscript, reactants, products, phase script, and synthesis. Remember, this week we're focusing on synthesis. And today we're going to be looking at making water. the synthesis reaction we're going to be studying.
Mister, what do we put for A?
You mean in the document?
Yeah.
For A, you mean here?
Yeah, and then we took that part yet? I don't think you're presenting, by the way.
Well, oh, I'm not presenting. Let me see. Just a second. So you mean here where it says question, what patterns do you see?
Oh no, the one like below that in like the yeah, that one. No, that one.
This one? This is for people who are more advanced.
Oh no, the one below that one.
Below this one, we'll get to in a second.
Okay.
We're not doing it yet. So, let's see. So we're going to be just doing a little background stuff, getting you set up. And then Wednesday and Thursday, we're working on drawing the reactions. What I mean by drawing the reactions is a diagram representation of the particles. So from a balanced equation, I'm going to ask you guys to be able to draw out the particles as they represent the equation. And that'll be Wednesday and Thursday. And then Friday, we've got another demonstration for you guys that we're going to turn into a check-in. Oh, there is extra credit, by the way, homework that's due on Thursday. I noticed that a lot of students have trouble counting atoms. So you can't balance an equation until you've counted atoms. I would highly recommend most people try this for homework. I was going to try and do it in class, but we don't have the time in the schedule right now. Whoops. So that's up on Schoology as well. So if you haven't done so already, I need you to make sure you have these guided notes opened up in front of you. Because as we're going through the presentation for the rest of the period and throughout the week, this is where you're going to be doing your assignment. All right, so I've got a cool little video for you guys. This is based on The Martian. Eve, would you mind unmuting for a second so I can ask you a question?
Yeah.
So I'm going to ask you some questions that you can get straight from the slide here that you're looking at. What kind of reaction are we studying this week?
What? Sorry.
What kind of reaction are we studying this week?
Synthesis reactions.
Yeah, synthesis. Now, you guys took biology last year. What is a reaction you guys learned about that was a synthesis reaction?
Photo?
Nope. It has the word synthesis in it.
I think he said photo.
Who did?
I think June, didn't you say photo?
Oh,
Yeah, photosynthesis. I was like, what?
I thought you said soda. Sorry. So you're right, photosynthesis. What that means is photo, light, synthesis, make. You make things with light. Plants make sugars with light. That's a synthesis reaction. So we're going to look at a synthesis reaction where we're making water. All right, you guys can hear me, I hope. So this video I'm going to play, you're going to be thinking about what are the reactants and the products of this reaction. Let me know if you can't hear it.
Hey people, welcome to the planet Mars. Well, it's actually the Utah desert. However, the guys behind
We can't hear it anymore.
about the possibilities of living on Mars.
I think you have to present tab on that one.
And here I am, stranded, just like Mark Watney in the film.
So you can't hear it?
We can hear it through your classroom now, but it's really bad. Like the audio's like from the classroom.
Even when I muted myself?
Well, when you did that, everything got muted. I think you have to
Okay.
present tab on this one.
Oh, yeah, that's right. Thank you. I forgot I was.
Yeah, it's
I
weird.
hate to do that. Yeah. Woo.
We'll get it figured out.
Just so many things to remember.
Yeah.
All right.
Don't get violent, Eve. We'll get this figured out. Yeah, there it goes. Now it's working.
Hey people, welcome to the planet Mars. Well, it's actually the Utah desert. However, the guys behind the new movie The Martian kindly invited me to visit this place. Specifically to the Mars Society Desert Research Station, which is a facility run by scientists where they research about the possibilities of living on Mars. And here I am, stranded, just like Mark Watney in the film. Well, kind of. Now, if there's one thing I'm going to need in this place, as well as food and air, it's water. And in this video, I'm going to show you how to make water in the same kind of way that Mark Watney would have had to do it on Mars. Now, the guys at the research station have kindly set up this nice demonstration for me to show you how it's done. So let's go through the apparatus you'll need. We'll be creating water by burning hydrogen, so a compressed tank of hydrogen will be needed. We'll also use a condenser glass to collect the water. The red thing is used as a weight to keep it in place. Now this spiral tubing contraption attached to the clamp is used to help cool the mixture of hydrogen and oxygen. There's also a small valve on the left hand side, which is where I'll be attaching the hydrogen flow. The hydrogen and oxygen will be burnt in this large flask, which will be placed upside down on top of the contraption. We'll also use a fan to help with the cooling process, and a vacuum to help suck through the water. Right, let's get to it. First of all, I placed the large flask over the cooling tube and hydrogen valve. I placed the other side of the tube with the rubber stopper into the top of the condenser flask. Then I attached the pump to the condenser flask. Just need to attach the hydrogen line and then turn on the fan and the pump and we're ready to go. I allowed a small amount of hydrogen to start flowing from the tank. Now comes the dangerous part, igniting the hydrogen. Luckily for me, it didn't exactly explode. Now, it doesn't look like much is happening, but in fact, the hydrogen is burning with the oxygen inside that flask. The flame is actually invisible. I then made sure the seal was tight and allowed more hydrogen to flow through. After a minute or so, water begins to condense and drop into the glass. The condensed water from the burning of the hydrogen and oxygen is cooled with the aid of the tubing and the fan, and then gets sucked through into the glass via the pump. And there we have it. That's how you make water on Mars. Now that I'm nice and rehydrated,
Okay, folks. Now that you've seen that reaction, and they said the reactants multiple times, I want you to put in this A box that June was asking about, what are the reactants and what are the products of this reaction? So put it in this document. We've got about 2 more minutes.
And if you're stuck, just remember, you know what the product is. He's holding it. Miss Robin, you might want to switch your microphones so that you're back on the mic you were on before.
I'm sorry?
We're picking you up through the different microphone than you were before.
Okay, I'm gonna have to take a look.
Iana, heat is what is causing the reaction to occur. We're adding the flame to the reactants, but what is produced in the end will tell you what's there in the reaction side, right? Because the same elements have to be on both sides.
Okay. I don't think you guys heard what I said before. Can you hear me okay, Mr. Ritchie? Thumb up if you can. Cool.
Yeah,
So I'm gonna ask these 3 people to help us with that space that we need to put stuff in. Francisco, I'm gonna ask you first, then Iana, and then Jackson. Francisco, are you out there? Cool. So can you tell me one of the reactants? Yeah, awesome. So hydrogen's one of them. Let's see. Iana, do you know what the other reactant is? You there, Iana?
Yeah.
So what is the other reactant? We've got hydrogen.
Um, Nitrogen?
Not nitrogen. It's a different gas that we breathe, that we use. What do you breathe in that you can use?
Oxygen?
Yeah, there we go. So we've got
Oxygen.
oxygen. And now lastly, Jackson, are you out there? Cool. So what is our only product in this reaction? Can anyone help Jackson out? What were we making?
Yeah, Jackson,
Yeah,
what's
water.
the holding.
So,
Water?
Yep. So if you know the elements that are in the product, then you also know the elements that are in the reaction, right, guys?
so putting together what you guys said, I put in H2O plus O2 gives you, H2 plus O2 gives you H2O. So that's what you would put in for the complete reaction. The reactants are obviously on the left side. The products are on the right side. Cool.
And then actually, Iana brought up the good point earlier that if we were drawing this on paper, we might indicate heat or fire.
Absolutely, yeah.
Good job.
Because it is warm. All right. So the last thing that we've got to do with the 3 minutes we have left, you're going to look at this definition for chemical equation. And on that sheet that you're putting things in, you're going to write your own definition of a chemical equation. And I'll read this off for you guys. It says, chemical equation is a representation of a chemical reaction. The formulas of the reactants on the left are connected by an arrow with the formulas of the products on the right. So this right here, where I highlighted in blue, is where you're putting this.
If you're having trouble getting started, you might say something like a chemical reaction, a chemical equation shows, or a chemical equation diagrams, or a chemical equation presents. Those are some verbs that might help you get started.
Must we write it on A definition of the chemical equation?
Yep.
Okay.
Oh, sorry, Mr. Robin.
You're all right.
Lunchtime.
Distance as you leave today. Please be sure to leave campus as
Mr. Uber,
Yes.
you put an extra credit. How much does it work?
It should. Are you having trouble opening it?
No, but it didn't show me, Mister.
You mean when you open
Oh.
it, you were there?
Let's see. No, it didn't show me, Mister.
Okay, let me see. It's showing on mine, extra credit. Let me show you where it
Abdullah,
is.
sometimes if you click on the name of the assignment again, like where it is at the top of the page when you open it,
Yeah.
it'll send you to try clicking on the name of it again.
Okay.
Some attachments are weird like that.
All right, folks, that's all the time that we have today. Please, please, please make sure you're up to where we've left off. I don't want these turned in with spaces missing. Take care of yourselves, and I'll see some of you guys tomorrow.
Tomorrow.
Bye,
when is this due?
mister. Have a good one.
Bye, Jen.
When is this due?
The whole thing is going to be due by Friday.
Still
Okay. Okay.
And we're going to be working on it in class.
Mister?
All right, just a second. Let me get to Caleb. He had his hand up. What's up, Caleb?
Oh, I think he left.
He left. Okay. Let's see. Abdullah, what question do you have?
Mister, you remember the assignment that we did last time? My grade went down, and then I told you to check.
Yeah, and I'm just remembering I didn't check it. That's still on that
Same.
card.
My grade
Okay.
went down.
That's probably what
Okay.
Caleb was asking about too, if I know Caleb.
Okay. So your grades went down. So what I'll do, if you guys can hang on just a second, let me check the grades because I might need to adjust them. Let me see. Yana Giddens. And Yana, I'll look at yours first since I think you asked first. Yeah. Yeah, that's all I had to do. I just need to give you credit for whatever you put in. So Yana, you're back up.
Okay.
And let me see, Ahmed. Oh, sorry, Abdullah. Let's see. Sorry, I've got a friend Ahmed, so I always just call you Ahmed for some reason.
What time are you guys available on Mondays?
I am available, let me see, at 1:30. And if you look at, if you go to the page for this course, it's listed there at the top.
Yeah.
Yana, you could catch me at like 9:30 if you just shoot me a message if you want to meet at 9:30. Okay.
Okay. I'll shoot you a message.
Yeah. Make sure though, if you do that, make sure you show up because I will be like, carving the time away for you. Okay.
Okay.
But yeah, that'll work.
Bye.
Bye,
See you
Mr.
later.
Oh, Yana. Oh, she's gone. Never mind. I'll ask her tomorrow. Bye, Mr. Robin.
See ya.
See you tomorrow.